This is Algebra 1, Lesson 21A, the product rule for exponents. We're going to be doing examples 21-2 through example 21-4. Here's example 21-2. Let's simplify. Now this is all one big term. There's not any plus or minus signs. We can just look to see what our bases are. I see here that I have a base of x, and that matches with this base of x. So I know I'm going to have a term, or not a term, I'm sorry, a variable x, but raised to what power? What exponent? Well, I have 2 of them here, and then I have 3 of them here, so that's a total of 5 of them. Okay, now let's look and see what other. We took care of this, and we took care of this. Let's look at our y's. We have a base of y and a base of y. And this one is a 3, and this one is a 2, so that's going to be y to the 5th. And then I look to see what else I have. We took care of those. And I have this lonely little m to the 5th left over. Now, there's several different ways that I could write that. I could write that in a different order, and that would totally be fine. I could write y to the 5th, x to the 5th, m to the 5th, okay? Doesn't matter because it's okay to multiply in a different order. And there's lots of other different ways we could do it as well. But as long as you have the base correct and the exponent correct, you got it correct. Now, here's a definition that we're going to need, and it's a short one. X to the first is just equal to x. If they don't write an exponent, it's a 1. Okay, so what is 5 to the first equal to? Just 5. What would be equal to 7? Well, that'd be a 7 to the first. And x to the first is just x. These are all some little examples of this definition that you're going to need to remember because of this example and others like it. Example 21-3 says to simplify this. Again, I want to emphasize this is all one term. There are no plus signs, no minus signs, and you're going to want to look for that because it would be done differently if it were, and we'll talk about that in a couple videos from now. So here I can see I have an x and I have an x cubed. There's no exponent here, but we know that that means there's 1, right? So that's going to be x to the 4th. Because I did the 1 plus the 3. Now I'm going to look at the y's. I've got y and y squared. Is that going to be y squared? No, because there's an exponent here that we don't see. There's a 1, so that's y to the 3rd. So our answer for this one is x to the 4th, y to the 3rd. Example 21-4, we're going to look at each variable separately. We've got m, and here's another m, and here's another m. Let's look at their exponents. There's a 3 here. What's here? There's a 1, and then there's a 2 here. So 3 plus 1 is 4, plus 2 is 6. All right, let's see what else we have. Well, I have some p's. Here's a p, and here's a p. This one doesn't have an exponent. I know there's a 1 there. So that 1 plus this 5 would give me p to the 6th. Then I have an x, and I have another x. This x doesn't have an exponent, so I know there's a 1 there. That 1 and this 3 gives me a 4. So my final answer is going to be m to the 6th, x to the 4th, p to the 6th is the way the book writes it. Now notice I had them in a different order. But is that the same? Yes. Then I'm going to write it out the way the book does. They wrote it m to the 6th, x to the 4th, p to the 6th. And it goes into detail below this example in your textbook that there are 6 different ways you could write this, and they're all equivalent because the order of the factors doesn't affect the product. Remember, we've learned about the commutative property. So if you're checking your work and you see that they wrote an answer that's multiplied in a different order, that is totally okay because of the commutative property.